Chapter 7, Dimensional Analysis, Similitude and Modeling. So let's start with definition of dimensional analysis. Let's say you're working with Airbus or Boeing, something that makes plane, and you have new idea about a plane. You have some new design in your mind, or you are working with a car company or a ship design corporation. In that case, you have an idea to build a new ship or build a new car. Whatever your idea is on paper, and you want to know whether it will work in reality. And if that's the case, you can't really go and build a full-size prototype and start testing on it. You don't have money, you don't have time, you don't have resources. So what you do, you build a small model like this plane and you test that model in wind tunnel, or if it is a ship, you test that model in a water tank. The method, the scientific method to do this testing, to do this experiment on the model, a small size model, is known as dimensional analysis. So dimensional analysis is used to determine the size and the dimensions of a model to be used to simulate a full scale prototype. So it's a simulation. So you are going to build a small car or small ship or a small plane and going to test it. All that science is known as dimensional analysis. Dimensional analysis is a very powerful tool, not just in fluid mechanics but in many other disciplines. Let's say civil engineering. You have an idea, you are a civil engineer and you have an idea to build a tallest building in the city, and you want to test wind forces on that building. So what you do, you build a small model of the building, take it in wind tunnel and test your wind forces on the building. So the science to do that, scientific method to do that, is known as dimensional analysis. This one is the model of F-18 and they are testing it in NASA wind tunnel. So many times it is not physical to run experiments with prototype or full size model because of time and money. So let's say you have this space shuttle model here. You don't have, of course, resources. If you have a new idea about space shuttle, you don't have resources to build actual space shuttle. It is very expensive. So you are going to build a space shuttle, a small model. This one is 3% space shuttle model. You are going to test it in NASA wind tunnel, and that's the science, is dimensional analysis. So instead we create a small model, run an experiment on that model to predict how prototype will behave under similar conditions. So how this thing will behave in reality, we try to predict that. So dimensional analysis will allow us to predict the relationship between model and prototype. So whatever the relationship between model and prototype, we can predict it, and then giving it same dimension and same testing condition is known as similitude and modeling, and we'll go through that one by one. So how does this process start? Sometime in 1908, early 20th century, there was this guy named Edgar Buckingham, and he understood the problem. He was testing with something, and then he realized that we need a scientific method to do this kind of testing, because in the future more and more people will do this model testing. And then he came up with this method, and that method we call it as Buckingham-Pi theorem. Now Buckingham-Pi theorem is something that we use to get dimensionless parameters, and then we will see what are these dimensionless parameters. We call them pi terms, pi 1, pi 2, pi 3, and that's why we call it Buckingham-Pi theorem, and then we will see what that is. So what Edgar Buckingham said, that follow these 8 steps. He gave us 8 steps, and then he said follow these 8 steps and then you should be able to get dimensionless parameters, pi 1, pi 2, pi 3, and then once you have them, you can use those parameters to run your tests, to run your simulations or model testing, and then to understand the relationship between model and prototype. This is the scientific method, or at least the basics of scientific method he gave us. If you are looking at all these 8 steps for the first time, it's going to be very difficult for you to understand. You will not know what's happening. So it's better to understand these steps with an example, and that's what we are going to do. We are going to solve a few examples, and we are going to try to understand what this Buckingham-Pi theorem is. It's very simple. It takes time to understand, but once you understand it, it's very simple. So let's start with this example. In this example, what we have is a small pebble dropped into a liquid. So we have some liquid here, we are going to drop a pebble. Then it says the speed v of the waves is generated is function of density, wavelength, wave height and surface tension. So once you drop it, these waves are generated, and the speed of these waves is depend on density, wavelength, wave height and surface tension of the fluid. We want to determine the suitable set of pi terms using Buckingham pi theorem. So we want to find out a dimensionless parameter, so combination of these variables in such a way that it is dimensionless. We call them pi terms, pi 1, pi 2, pi 3, so on and so forth. And that's simply Buckingham pi theorem. So just for now, stay with me. We'll start with 8 steps. So step 1 for all the 8 steps. So step 1 for Buckingham pi theorem says, list all the variables that are involved in the problem. It means it's very simple. All you have to do is get your speed, density, wavelength, wave height, surface tension, and you have to list them. You have 5 variables here, and you have to list them in this form. You have velocity, you have density, wavelength, wave height, surface tension. So V is your dependent variable, and it is function of all these independent variables: density, wavelength, wave height, surface tension. This is a function, this is not a variable. So 4 variables dependent, 4 independent variables, 1 dependent variable, and then that's all your 5 variables. So list all the variables. It's very simple. Once you list it, then you go to step 2. Step 2 says, express each of the variable in terms of basic dimensions. What does it mean? It means that all these variables have a dimension. For example, this one, meter per second, that's the unit of speed or velocity. Density, wavelength, wave height, all these have some units. So you have to express them in the terms of basic dimensions. Now basic dimensions is mass, length and time, and these are our basic dimensions. So velocity is nothing but meter per second or feet per second. Meter is in length, s is in time, so I'm going to write down it as L1 t minus 1. So here I will get L1, and this is a denominator, I'm going to say t minus 1, and that's my basic dimensions, and I'm going to write that here, L1 t minus 1. Now the other also I'm going to write down as a dimensions. So here we have density. Density is kilogram per meter cube. Kilogram is mass, meter cube is length, L minus cube, L minus A, that's what I'm going to write down here. Wavelength is just a length, so L1. Wave height, again it's height L1. And surface tension M1 T minus 2. Why surface tension M1 T minus 2? Because surface tension is nothing but sigma is equal to Newton per meter. This Newton is again given as, I'll write down here, kilogram meter per second square, that's your Newton, divided by meter. Now what happens is, this is your Newton. Now here this meter and this meter cancels out, and then you left with kilogram second square. So kilogram is nothing but mass, second square is time to the power minus 2. So here I'm going to write down here for surface tension as mass 1, that's kilogram, and then time, that's s to the square, and that's a denominator, so t minus 2, and that's how this surface tension works. So my basic dimensions are again m, l, t, mass, length, time. These are my basic dimensions, and then it says express each variable in terms of basic dimensions, MLT. So I'm going to write that down. Velocity meter per second, L1t minus 1, density M1L, that's meter, that's a mass per unit volume, volume is L minus Q, so on and so forth, and that's how I'm going to write these dimensions. Now, once you are done with step 2, we are ready to go for step 3. But before that, what we do is that for some reason, Buckingham said that call these variables as k terms. So that's what we are going to do. We are going to call it as k terms, and then we are going to call these reference dimensions as r terms. So k and r, and we are going to write down the number. Number of k terms is 5, number of r terms is 3. For some reason he said, okay, call them k terms, call them r terms, write the number down. Okay, done. You are going to write that number down here. Once you have done that, you are done with step 2, and then now you are ready to go for step 3. Now step 3 says that find out number of pi terms. And number of pi terms means how many dimensionless parameter you are going to have. So number of pi terms is simple, it's equal to k minus r. So k is your 5, that's number of variables, r is 3 is equal to 2. It means that you are going to have pi 1 and pi 2. You have to find out what is pi 1 and what is pi 2. And that's the objective of this problem. Find out what is the value of pi 1 and pi 2. So that's what we are going to do in this problem. Then once you are done with step 3, step 4 says select the number of repeating variable where the number is required equal to the number of reference dimensions. It means our reference dimensions is 3. Now what I have to do in this step is out of 5 variables I have to choose 3 variables. How? 1, I cannot choose dependent variable. It means that whatever happens I cannot choose this one. Out of 5 I have to choose 3. You cannot choose dependent. Okay. And then out of 4 I have to choose 3 now, and it says that cannot include variable with same dimensions. So here if you look, wavelength has same dimensions L1, height has same dimensions L1, and therefore I can choose only one of them. I cannot choose both of them. So for this problem what I am going to do, I am going to choose one of these. I am going to choose density, I am going to choose surface tension, and then I am going to choose one of them. So here in this case I choose height, I choose density, and I choose surface tension. So step 4 is simple. Choose 3 out of 5, and that's pretty much it. Once you choose your H, density and surface tension, you are ready to go for the step 5. Step 5, in step 5 you have to remember this equation. This is called your pi term. This equation is ui, u1, u2, u3. Now in this equation what we do is that we take our variables selected in step 4 and then we put them as u1, u2, u3. So here h will become u1, density will become u2, and this one will become u3. And then whatever ui you have variable, I am going to take this v and then I am going to plug that in ui, and then I am going to have my terms as like this, or I can rewrite them in this format. So here v, then h raised to a, density raised to b, surface tension raised to c, and that's it. That's how I am going to write it down. Once I write it down, all I have to do now is to find out the combination of these 4 variables in such a way that it will become dimensionless. It means that the combination will be something like VH by density sigma. Something at numerator, something at denominator, dimensions cancel each other out, and then I'll get my first pi term. So all I have to do right now is to get A, B, C in such a way that this entire thing is dimensionless. So how am I going to do that? I'm going to use this part. Since the combination has to be dimensionless, I'm going to say that these are my variables. For velocity, I'm going to write down dimension for velocity, meter per second, L1 t minus 1, then height, then density, and then your surface tension raised to a, b, c is equal to 0, 0, 0. As it has to be dimensionless, I'm going to write down 0, 0, 0 here. Now, all my objective is to calculate values of a, b and c. How do I do that? So, pay attention now, it's very simple. Now here, what I have to do is calculate values of a, b, c. So, I'm going to start with, let's say, L or t, let's say. So here, for t, I'm going to say t is here, t raised to minus 1. I'm going to take that minus 1, I'm going to write down here. Then I'm going to see where I have t. I have t, I don't have t here, I don't have t here, I have t here. Now, I'm going to take that minus 2 here for t into c, I'm going to multiply that, and then I'm going to say minus 2c. So here minus 1 minus 2c is equal to, I have 0 here, I'm going to write down that 0 here. It's very simple. And then once I play around, I'll get the value for c minus half. Then I'm going to say m. I don't have m here, I don't have m here, m raised to minus 1. I'm going to write down is m is equal to, here I have 1b. I'm going to write down 1b here because 1 here, b here. And then I have m here, 1c. I'm going to write down 1c here, that's plus 1c is equal to 0. I have 0 here. So I'm going to write down and then I'll get the value of b. So because I have already value of c, I'm going to put that value of c here and I can calculate the value of b. Once I have that, I'm going to do the last dimension, length. Now length, you have L1, 1 I'm going to write that, then 1a I'm going to write that, and then minus 3b I'm going to write that here, and that's it. Is equal to L0, I'm going to write that 0, and then I'm going to take the value of b here, and then value of c. I don't have c here, so it doesn't matter. And then I can calculate the value of a, which is around minus half. And then I'm going to take these values, plug them back into this equation that we did before. Once you do that, it will look something like this, and you can rearrange it, and then you will get this part. V h rho divided by under root h rho divided by sigma. So here, if you can see here, we have raised to half, raised to half. So that's my raised to half. And then here minus raised to half minus sign, it's going to be a denominator, raised to half is under root, and that's my pi term. That's my answer that I'm looking for. So this one is the first answer that I get, and now I'm going to need another pi term because we are going to have two pi terms, pi 1 and pi 2. So for the second part, what I'm going to do is that I have neglected this lambda before. I'm going to take that lambda and put them as a ui, and then I'm going to keep these three u1, u2, u3 as a constant, and then I'm going to rewrite my expression here, and now again I have to do the same process and calculate the values of a, b and c. So let's do that. Let's calculate the values of a, b and c. Here we start with t. It doesn't matter where you start. You can start with, if you want, with m or t or it doesn't matter. So we start with t. So here I have t, which is minus 2c. Minus 2 is equal to c is equal to 0. C comes 0. And then you start with m. I have m here. 1b, 1c plus 1c is equal to 0. So b comes 0. And then finally L. I have L here, that's minus 3b. I have L here, so 1 first, and then 1a, and then minus 3b is equal to 0 because it is 0, so 0, and then you will get a is equal to minus 1. And then you can put these values as of a, b, c here. So this becomes 0, this becomes 0. So we can, anything raised to 0 is 1. So you can just write it as 1, 1. It doesn't matter. You can cancel it out. And then you will get this one and this one. And that's your term. Lambda raised to 1, h raised to minus 1. You can rewrite it like this one, lambda by h. And that's your pi 2. And that's pretty much the problem is. You have to find out this dimension, this parameter pi 1 and pi 2. Now, step 7 says check all the resulting pi terms to make sure that they are dimensionless. Now, you have to just check that dimensions for the numerator and denominator, they balance, they cancel each other out, and they will if you check. And then here also you can see they already cancel each other out. And then that's pretty much step 7. If they don't cancel each other out, you may have to go back, but right now they do cancel out. And then step 8, write down, it is in this form. Pi 1 is function of pi 2. So this is my pi 1 is function of pi 2. I'm going to write down my term pi 1 and pi 2, and then you are done with Buckingham pi theorem. It's very simple once you know what you're doing. So that's first problem. Let's do another problem for Buckingham pi theorem. In this problem, what we have is experimentation is required for typical fluid mechanics problem. Consider a steady flow of the fluid along with small, long, smooth-walled horizontal and circular pipe. So what we have here is a pipe, and the flow is going from point 1 to point 2. Now, as the flow goes from point 1 to point 2 inside the pipe, because of the friction, you are going to lose energy, and because of that, you are going to lose pressure. So you are going to get high pressure here, and as the friction goes down, you are going to get low pressure here. What we want to do is determine the expression for pressure drop per unit length. So that's your pressure drop per unit length, P1 minus P2 divided by L. So per unit length means per meter or per feet. And we want to determine pi terms by using Buckingham pi theorem. So here we have 4 variables inside this problem. Once we have diameter, we have velocity, we have density, and we have viscosity of the fluid. So let's start with step 1. Step 1 says list all the variables that you have in the problem. So variables, all the variables we have. First one, dependent variable delta PL is equal to, we have diameter, density, viscosity, velocity. 5 variables we have here. This is a solved problem from the book. So this delta PL is function of all these 4 variables. Write down the variables. Step 1 is done. Then step 2, write down their basic dimensions. So basic, my variables are here, and then basic dimensions will be like this. So basic dimensions, it means the form of ml and t. So for pressure per unit length, you will get your basic dimensions like this. Make sure that you understand this process. Its basic dimensions is nothing but unit. It's unit written in MLT form, mass, length, time, mass, length, time, MLT form. Diameter is just the length. Density is again same, m1 L cube. Viscosity unit, find out the unit for viscosity and then write it down like this one. You will get MLT form. And then velocity is again meter per second, L1T minus 1. Once you have this part done, write down your R terms. So these are your R terms. R terms is reference dimensions. You have 3 reference dimensions, M, L and T, and you have 5 variables. So I'm going to write down number of K terms is 5 and number of R terms is 3, and that's pretty much step 2. Once you are done with step 2, all you have to do now is get the number of pi terms in step 3. Number of pi terms is nothing but K minus R. So 5 minus 3 is equal to 2. It means that in this problem 2, I'm going to have pi 1 and then I'm going to have pi 2. And my objective is to calculate what are these terms, pi 1 and pi 2. So that's what I have to do. So number of pi terms is 2. Then step 4 says that out of these 5 variables, find out 3 variables in such a way that it cannot include dependent variable. It means that you cannot include this one, and then out of these 3 you cannot have variable with same dimensions. Now what this problem I'm going to do is that I'm going to choose this variable, then this one and this one. I'm going to avoid to choose viscosity for now because it has some complex unit, and this is something that you will come with more practice and experience. For now, what I'm going to do is I'm not going to choose viscosity, and then I'm going to choose 3 variables which have relatively simpler unit, and that's the game. Choose something with simpler unit. Diameter, density, velocity, they have simpler unit. I'm just going to go with that. Diameter, density, velocity. You're done with unit. After that, step 5, you have already chosen your 3 variables. In step 5, you write this one, u1, u2, u3, and here your u1 is d, your u2 is density, your u3 is velocity. So here I'm going to rewrite it like u1, u2, u3 here, and then for the first variable I'm going to take this delta PL as a ui, and I'm going to write down that here. So delta PL d raised to a, density raised to b, b raised to c. Now our objective is to calculate values of a, b, c in such a way that combination of these variables will be dimensionless. And that's what we are going to do. So for that, since the combination has to be dimensionless, I'm going to write down this thing in terms of basic dimensions that we did in step 2. So for density, I'm going to write down like this. For the my pressure per unit length, pressure drop per unit length like this. Here I have diameter, I have density, and I have velocity is equal to 0, 0, 0. It means that I have to make this one dimensionless. So let's do that. Let's do this one as dimensionless. So here we start with t. T I have minus 2 here, and then t minus 1c here. So I'm going to write down minus 2 minus 1c is equal to t 0, 0 here. And I'll get the value of c is equal to minus 2. Then for m, I have m here 1. I don't have m here 1b, 0, 0, 1 plus 1b. I'll get value of b is equal to minus 1. And then for L, I have minus 2 here, minus 2, and then I have minus 3 and b here, minus 3b here, and then before that I have 1a here. I'm going to write down plus 1a here, and then I have 1c here, that's plus 1c. I'm going to write down that here, and then this one L is equal to 0. I'm going to write down here, and then once I have that, I'm going to put my values of b is equal to minus 1 here, and then c is equal to minus 2 here, and then I'll get a value of a as a is equal to 1. And once I have that, I'm going to take these values and plug them back in this equation, and then I'll get something like this: delta PL d raised to 1, density raised to minus 1, b raised to minus 2. Once I have that, I'm going to rewrite them like this, and that is my answer. That is my first pi term. So I got my pi 1, and then I'm done with my first part. Our objective again, get this one, combination of these parameters in such a way that it will be dimensionless. Now if you check the dimensions, it will have numerator and denominator will have same dimensions, and then it will cancel out, and this term will be dimensionless, m0, l0, t0, and that's what we are looking at. Once you are done with pi 1, we start with the next term. We are going to have 2 pi terms. So now what we do is that, if you remember, we neglected viscosity. Now I am going to take that viscosity, and then I am going to put that ui here. I am going to replace that delta PL to here. I am going to keep that u1, u2, u3 constant. So here I have viscosity, and then the rest of the 3 u1, u2, u3. I am going to now redo my calculations for this one. So here I have viscosity, and the rest part here stays same, is equal to 0, 0, 0. I have to make it dimensionless. So now we start with again t, minus 1 here, minus 1c here, minus 1c, 0 here, c is equal to minus 1. And same way you have to do your calculations. For m, 1 here, 1b here, that's it is equal to 0. You get b, and then same way for L, you get this part, and then you will get all the values of negative 1, negative 1, negative 1, and then you will get, you put those values here, and then you will get second pi term as pi 2 like this. Now initially we did not choose viscosity because viscosity and the other 3 have same dimension, and that's why we chose 1, 2 and 3, and we avoided viscosity to choose because of this pi 2. So that is your final answer, pi 2. Once you are done with pi 1 and pi 2, then step 7 says check all the make sure that they are dimensionless. So in step 7, what you do, you go back, you see the dimensions, you see they cancel each other out. If they do, you are good. If they don't, then you may have to go back and you have to do the process again. Check the dimensions, check the dimensions. Once you are done, write down in this form, and that's pretty much your answer. That's it. That's what you have to do. That's what you are looking for, dimensionless parameter, the combination of variables which is dimensionless. Now, let's do one more problem. This one is again from the book. What we have is a plate here, and a thin rectangular plate is having a width. It has width W and height H. It has some height, moving in a stream of fluid. So a stream, it's moving in a stream of fluid. Let's say if I can play it in here. So if you look at it, this is the plate inside the fluid, inside water, and it's moving. And as it moves, it creates a drag force. So here, the drag force is created. So this is the drag force we have. And that drag force is a function of width, height, viscosity, density, and velocity. And we want to develop a suitable set of pi terms to study this problem experimentally. So again we have to do pi 1, pi 2, pi 3, pi 4, whatever the values, we have to the combination of these variables in such a way that it will be dimensionless, and that's what we want to do here. So here, step 1, we are going to start with list all the variables. So all the variables, drag force is a function of these 5 variables: width, height, viscosity, density, velocity. Done. List all the variables. So 6 variables I have, I'm going to list them. So this D is drag force. It has a dimension of force. It's Newton. Step 2. Write down your K terms and write down your R terms. So, and then write down their dimensions. So these are my K terms. This one, my R terms, and then their dimensions. So this one is force. Force is kilogram, meter per second square. So here kilogram is mass, meter per second, meter is length, per second square it's time. So here my ml t minus 2 for force, width is length, height is length, viscosity, density, velocity. Get their dimensions and put them into mlt form, mass, length and time, and that's your step 2. And that's pretty much it. You know K terms is, number of K terms is 6, number of R terms is 3. So 6 here, 3 here, and you're ready to go for the next step, step 3. Step 3 says, determine the number of pi terms. K minus R, that will be 6 minus 3 is equal to 3. It means here I'm going to have pi 1, pi 2, pi 3, and I have to find out what are these values. Combination of my variables will be dimensionless, and I want to find 3 of these combinations: pi 1, pi 2, and pi 3. So now step 4 says select a number of repeating variables. So out of these 6 variables, I have to choose 3 variables in such a way that cannot include dependent variable. It means that I cannot include this part, then cannot include variables with same dimensions. So here width and height has same dimensions, so I'm going to allow to choose only one. Let's say I'm going to choose width and I'm going to choose height for now. And then for the others, viscosity has complex dimensions, I'm going to avoid to do that. So I'm going to choose, let's say, width, density and velocity. That's what I do here. Width, velocity, density, and that's my variables are selected. Once I select these variables, I move on to step 5. In step 5, you need to remember this part. U1, U2, U3. So this is U1, U2, U3 is nothing but your U1, U2, U3. That's what you selected in earlier step 4. So I'm going to write that down here, and then UI is nothing but your dependent variable drag force. So my drag force is here, the rest part is there, and then I'm going to write down in the form of A, B, C. My objective is to calculate values of A, B and C. That's it. So now I'm going to say, since the combination has to be dimensionless, I'm going to follow the same process. Now you should know the drill, how to do that, how to get values of A, B, C. If you want, you can pause the video and find out the exact values of A, B, C and see if they match or not. So that's what we are going to do. We'll get the values of A, B and C. Now let's see if you can get the values of A, B, C. You start with, let's say, T. It doesn't matter where you start. Let's start with T. So T, I have minus 2 here. I'm going to write down minus 2 here, then minus 1b here, minus 1b here is equal to 0, 0, and then I can get the value of b minus 2. Then for m, 1, 1c, 1 plus 1c is equal to 0, c is equal to minus 1. For L, 1, 1a, 1b, minus 3c, so 1, 1a, 1b, minus 3c is equal to 0, and then you will get value of a. So here you can put this value c of c here, value of b here, and then you can calculate value of a, which will come minus 2. Once you have those values, put those values back into this pi 1 equation, and then you should be able to get your pi 1 like this. Drag divided by density, velocity square, w square, and this is your dimensionless term, and that is your first answer. Now you move on. Remember, you are going to have 3 pi terms, pi 1, pi 2, pi 3. So now you are going to move for the next part. Here repeat step 5. So now we neglected 2 of the variables. We neglected width, we neglected height, and we neglected viscosity. So now I'm going to replace that with height here. First UI, I'm going to take that here as a height. I'm going to take this out, and then I'm going to keep my U1, U3, U1, U2, U3 same, and I'm going to do the same process. I have to make the combination of these 4 variables dimensionless, and if you do that, if you follow the same process, what you will get is that b is equal to 0, c is equal to 0, e is equal to minus 1, and then you will get your final pi 2 as h by w. That's what the second answer for this problem. Once you are done with this step, the last for the last part, pi 3, you choose now this viscosity. So that's what we are going to do. Viscosity, we are going to take that here. Viscosity is plugged in back here. Rest 3 stays same, and then I'm going to do the thing. So here I need to know values of A, B, C. So I'm going to say that my width here, velocity, my density here, and my viscosity is here. I'm going to calculate the values of A, B, C, and then it will look something like this: -1, -1, and -1. So you will get your values of A, B, C as -1, -1, -1, and finally you can find out pi 3 is equal to u minus 1, w raised to 1, v raised to -1, density raised to -1, and then you will get final value of pi 3, and that's pretty much it. Step 7 says that check all the results. So step 7, you will what you have to do is that you have to go back, you have to write down their dimensions and see if they have same dimensions. Numerator, denominator, same dimensions, cancel out. Pi 1 is good, pi 2 is good, pi 3 is good. Once you are done with that, you are done with step 7. If you are not, then you have to go back. But if they cancel each other out, if it is dimensionless, you can move on to step 8, and then you can write down your final relationship in this form. Pi 1 is function of pi 2 and pi 3, and that's pretty much it. This is your pi 1. Pi 1 will always have your dependent variable. So pi 1 is function of pi 2 and pi 3, and that is your answer, and that's pretty much it. And that's how you use this Buckingham pi theorem. You follow the 8 steps and you should be able to do that. Practice this problem. These are solved problem of the book. Read the book. If you have a problem, set up an appointment with me where we can discuss this thing. It's very easy. Let me know if you have any issues with that. So for now, chapter 7, we'll stop it and we'll continue this chapter 7 in the next video or in the next class. Thank you, and that's pretty much it.